How do MRI machines and starter motors create magnetic fields that are strong enough to move objects or flip atomic spins? Because they use these coils of wire. These are solenoids. And in this video, I hope you build a deep visual module of how these work and why wrapping wire turns a weak magnetic field into an extremely powerful one. So first, let me help you visualize a solenoid. Here's a long coil of many loops, and the magnetic field that goes through these loops looks something like this. You have one up here, and you have one going through them right here. Now you also have these going through like this, coming through this way and exiting out this way. Why does this happen? This coil, each loop creates a magnetic field, and all of the loops together combine to give them a strong, uniform field. Inside the solenoid, the field lines are dense and very nearly parallel, which means that it's very strong and it's nearly uniform. Outside, the lines spread apart, so it's weaker and it's no longer uniform. Because remember, when it comes to field lines, the density, so the spacing in between, tells you how strong it is. So inside is very packed together, very strong. And then it starts to split up, become more sparse. When this is wrapped around iron, we call this an electromagnet because the iron boosts the field massively by becoming magnetized itself. Here's the formula for a magnetic field inside of solenoid. B, which is magnetic field measured in Tesla, T, equals the permeability of free space, which is the constant, times the number of turns, times the current, divided the length of the solenoid. So how long it is. In the description, I made a free cheat sheet with this formula on it. And this constant, I'll chuck it on there as well. This constant is 4 pi times 10 to the power of negative 7. Only the number of loops per unit of length matters, not the diameter. This is why type solenoids with more loops per meter gives stronger fields. How dense it is, that's what matters. Here's an example problem. Say you have a circuit setup, and right here, you have a solenoid, and it powers a doorbell. Imagine it has 100 turns, so that would be the number of turns n, and it's 0.25 meters long. Along it, it carries 2 amps of current. The goal is to find the magnetic field inside, so these lines. Let's use our formula. I've written it out here. We can go ahead and plug all in our values. So first is the constant, which is the permeability of free space, 4 pi times 10 to the power of negative 7, multiplied by the number of turns, which is 100, current, which is 2, divided by the length, 0.25, giving us 1 times 10 to the power of negative 3 teslas of field strength inside of here. You could also call this 1 millitesla, which is strong enough to move iron parts like a switch or a bell striker